If there's no light, you can't see. Once we turn on the light, we can start to see things. And if we start to change the light, move it closer to the object, we can see that the light beam changes. These changes are caused by the beam angle, which is the degree that the beam is spread over. So I have a small LED flashlight from across the room, and you can see that the light is very dim and pretty spread out. As I move closer, you can start to see the circle of the light get tighter and brighter until it shines very brightly and very hotly on the drum. You'll also note that the shadow on the drum grows larger and larger and becomes more and more well defined. If we move backwards, you can see the whole thing in reverse. The light becomes dimmer and more spread out until all you have is the two-dimensional look of the drum. The type of light that we use in order to shape our different beam angles is called the ETC Source 4 ellipsoidal. And here's how it works. So imagine these cutouts are different degrees of light. The largest one that you see here is going to be our 50-degree light. This one is going to be our 36-degree light. And this one is going to be our 24-degree light. And what we have here is a representation of what you saw with the flashlight in the drum. As the beam gets wider, it becomes a shorter beam. And imagine that this beam would be much dimmer here than it would be up here. Since this beam is tighter, it can go longer and it will be brighter at the end than this one will be here. And the same thing with this beam here. The tighter the angle, the farther it can go, and the brighter the beam will be at the end. If you had a 50-degree light and your focus was this would still be brighter than 24-degree light where your focus was this length. But at each individual length, the thinner the degree, the brighter the light will be. So we've talked about how the shape of the light affects the quality of the light. What we're going to do now is talk about how the direction of the light affects the quality of the light. The direction of the light also plays a role in what your subject looks like. As I move this flashlight around, you can see that my face actually changes. As the shadows grow fewer on my face, as I move it up, until it reaches a point above where I get dark circles under my eyes. If I move it back down, those circles disappear and most of my shadows disappear. As I move it to the side, look at the shadow of my nose as it goes across the face. And my face becomes more three-dimensional and you can see more of the texture. If I keep going across, what will eventually happen is that one half of my face will be completely in shadow. Now I'll begin moving it down, and the shadows change once again. And what you can see now is a very spooky look with a lot of upthrown shadows. Okay, let's see how this is going to work on our stage. So imagine for a moment that this is our stage. We have our proscenium wall here and here. We have our apron here. We have our upstage cyc here. And then we've got the stage right wing and the stage left wing. And we need to light from the front, from the catwalk. So let's imagine that the catwalk is over here, just right at the bottom. If we were to take a 50-degree light, we could shine it there, but one of the problems is that it would hit the proscenium walls, and it would be so dim by the time that it got there that it would only light the apron, and it would only light the apron pretty badly. So that's not going to be the light that we use to light from the catwalk. Instead, what we're going to do is we're going to use 24-degree lights. And you can see that they are sharp focused and they travel for a very long distance. But you'll notice that we don't light up a very wide portion of the stage. using the 24-degree lights. So what we're going to have to do is we're going to have several 24-degree lights coming down here in order to light all the way across and to be able to light it evenly. We could try to light the whole thing with one 50-degree light, and it would cover it, but it would be very dim by the time it got to the apron, and it wouldn't light up the rest of the stage at all. Now you'll also notice that even the 24-degree lights don't go all the way back. So what we'll also have to do is we'll also have to have some front light that we hang on stage so that it travels to the back. And for those, what we'll use are the 36-degree lights, because the 36-degree lights have a wider spread, but also have a shorter throw. So if we were trying to light the rear of the stage with the 26-degree light, we would have so much extra light that it would be too bright once it got to the back. It would wash out the cyc, and it would be very uneven. So what we do is we use a wider beam on stage to light up stage, and we also need fewer lights there, which is good because we need lights for other things as well. We need lights to light from the side to give us some of that definition that we were talking about. And for that, what we'll probably use are the 50-degree lights. Because what we want to do is we want to have different color lights coming from stage left and from stage right. And so if we have a 50-degree beam, it will become very dim this way and very bright over here. And that's okay because it will mix nicely with the light that is coming from this way, which will be the opposite. It'll be very bright on this side and it'll get dimmer on this side. And another nice thing is that since it's so wide, you only have to use fewer lights to save space and to save money.